Hey there, what's up everyone? It's been an interesting morning. GitHub being exploited. What has happened? Well, there's been a lot of speculation around, hey, this is due to some PyPI packages, some VS Code, some other packages linked to Microsoft. We're here to demystify. We still don't know what exactly happened. Microsoft kind of confirmed, or GitHub confirmed, that this was linked to an extension. But let's look at the timeline. Apparently, they've been compromised since a little bit of time due to a VS Code extension. They were investigating yesterday, 8 hours from this morning, so roughly midnight UK time, Europe time, and fairly early morning in US Central Time. After that, they've been disclosed at 5 a.m. Central Time, GMT time, so roughly middle of the night. They've been working throughout, and they discovered there was some machine compromised by a VS Code extension. So we originally speculated that where the compromise was due to some malware linked to the particular code or particular packages that were linked to Azure. That was still a problem, but wasn't the driver for this. We wrote a detailed blog in here with kind of the timeline of all these TeamPCP, with several attacks from Trivy, Checkmarx KICS. All of these web packages signed and officially sanitized. So there is definitely an attack surface. TanStack got compromised, SAP got compromised, Axios got compromised. So a lot of these timelines happening very, very quickly shows a criticality in this package manager that we're going to explore later. And it's not just PyPI or NPM. It can be anything. And then today we get this GitHub compromise. So if we want to drive back, so NXCreds was potentially the one compromised. There's been some speculation around. If we look, yeah, Matt confirm it. There's been some confirmation that yes, NX was probably the one driver with 28 install or potentially 6K install. So the blast radius of this could be wider than, actually, let me capture this for the next note. This story is evolving quite fast. And yeah, BoxSorter originally confirmed this was the particular problem that compromised this, and 3,800 were potentially linked. So we speculated that was the NX console that was previously kind of compromised, and that follows the ANV compromise a few days ago. There is another blog here. We can't write fast enough blogs or report. This is evolving quite quickly. There's been copycat of copycat of Shai-Hulud after TeamPCP open source their kind of Shai-Hulud vibe coded solution, and then after that 600 repo got compromised. So this is just an escalation, I think. This, even though we don't have, well, we kind of have the official confirmation or unofficial from this information, but it's not yet. So let's discuss a little bit, how do you protect against this? Well, one of the problem is code extensions. So what do you install in your system, and what those things are maliciously pulling. You need NPM firewall, you need malware firewall, you need a lot of things. You're not going to fix things with specific solution because you need to have defense in them. So if we want to take a step back, this way to protect this is complex, and it's probably scattered, variegated. So normally you would just put an npm command, and this goes to the package manager, and this goes to the package. Normally you wouldn't do that anymore. You wouldn't go directly to that. You only have a proxy or a solution in your agent. But the way people develop things right now is not YOLOing, hey, I have Claude Code, can you build these things for me? That's probably the bad way to go. There is a solution for that. That is basically putting a set of layers. There isn't a solution that fits all. There is Claude Code that is really the agents, or the Claude Code or Codex, they call the cloud version, and then it continue here. So what you're looking at in your machine is really a harness that executes some function or some iteration, and then does some callback to the cloud version of things and does back and forth. So that is where you want to rule that specify do this, do not do this, and more importantly, to fix this particular problem, those are the pre-hook session or the hooks that blocks particular session from doing something malicious. Now, these are blindfolded rules. If they don't have a logic or if they don't have an intelligence behind, they are pretty much pointless rule. So you need to have an intelligence like what we have for Phoenix, phx intel .security. Yeah, they basically have phx intel .security. They basically have kind of recurring malware or specific malware that you can go and kind of inspecting. Is this particular package a vulnerable package? Yes, no, why? Is it good positive, is false positive, and so on. So that's what you want in your system. But the hooks in itself will not do anything. They will react on an intelligent system that sits outside and basically make this decision. Also, the rule that you apply on the hooks, you don't want the rule in here because anybody malicious that act here or here could bypass completely those rules and say, hey, don't use this rule, just go ahead and use this package manager or override this. So you want the intelligence and the role management system outside your system so that if these get compromised, you can still block or you can still prevent. And that's a break clause that you have there. So this is a defensive layer. Now, these hooks can be compromised, so you need to force the agent to go through that. Now, the rules that you put in there are bound to the context, that is how much the harness or Claude keeps in memory. So some of the rule could potentially go outside, but the pre-session hooks and the post-session hooks or the flash session hooks, that is basically at the beginning of a session, at the end of a session, or when you compact or when you do specific operation, those are the things that you want to specify in terms of hooks. Now, we have open source the agent firewall, that is basically that install the hooks and prevents basically from a CLI scheme to prevent these things and basically pulled and does specific decision on packages, diff, intel, and then it also pulls into more packages, so it doesn't pull the now this is for Claude support hooks, but then Cursor, Codex, they don't support hooks yet natively. They are developing things. So we build some harness and some adaptation of these hooks to actually force it. In the future, we'll have more scope of this and more breadth of this. But right now, we are fairly limited with some of these harnesses. And again, all of this is related to the harness, that is Claude Code, Codex, and all of these tools that are limited by the hooks and how to build it. Now, this can still be bypassed. So you still want something that decide block or not block at the machine level. So that's a more proxy level that handle in case this conversation, so from Codex all the way to package manager, bypass these hooks. So instead of doing this and then doing this, if for some reason decide to bypass these hooks and goes directly. So at that point, you want to catch that call and block it at that point in time. But again, the block, no block will need to rely on intelligence and saying, these packages are being compromised, the VS Code has been compromised, the problem is still there. There is another version of BlueShield firewall that operate at CI level or CI/CD level, that basically when you build the project goes and check that verification. Now, this is not if you're building on your machine, but if you're building this through GitHub, Jenkins, Azure DevOps, or any other action. Again, there is no silver bullet. So once you push Claude Code into GitHub, so let's assume you have GitHub here, and then you have GitHub CI. At that point in time, you want the package firewall here. It is a little bit late, but again, it's another point where you might wanna block that particular packages from being pulled in because it's malicious. So those are the methods, again, to control this kind of behavior. Again, it's about defense in depth, so that if you don't catch the problem here, you might catch it here. or if you don't catch it at the machine, when you do a pull request or when you do a merge from a code perspective, those are the things that will help secure the software pre-package level. Because as you can see, the solution is complex and there isn't a silver bullet or an arrow that says, hey, just put this here and you'll be safe everywhere. Unfortunately, we build systems that are complex and are built in a complex way, and you really want that defense in depth layer that is here, 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 and here. They really look at defense in depth and look at different sessions where you can catch. Now, there is another argument on another topic from my good friend Jim. Let me see. Yeah, he was saying, use this prompt, and Jim is a fantastic trainer and he's doing a bunch of trainings on securing by default commands. So he was saying, reject CLD, reject dependency, be as close as the original code, so do not import basically package at random. And that is when you put rules and skill at, and that's when you build rules and skill at this level, so that when you write product specification, actually that product specification has the minimal attack surface. Again, these two controls are probably left and are great, but there isn't one solution that fits all. As you can see, there is rules before you start writing codes, but not everybody use those rules, or not everybody produce product specification or PRD, product requirement specification or design. Not everybody's going to use the same harness, so Claude Code, Codex, so some of these rules might be bypassed, but they will definitely use the machine and they will definitely use the package CI. So block the package at every layer so that you have one solution that fits all. So there's been some chat as well in the post. A good friend Matt did a live before. So AgentShield is one, Datadog is another one. It doesn't have intelligence, but it does protect. Aikido has another one. There's been some of the harness. Ultimately, is about the harness will not solve the problem. Sorry, the firewall will not solve the problem by itself. It needs to be a defense in depth layer firewall like we have in agent firewall or firewall by its own, so that you capture the problem at different level and different layers. And with agent firewall, you give kind of the best intelligence with the firewall manager. You cannot specify, hey, write a rule that blocks malware and require approval, or blocks it at CI level, or block it at agent level, but gives the context to the agent so that he knows, hey, this is malicious, this is actually doing bad things, so let's not use it, let's not do it. So this is our solution and my solution. Again, it's not a silver bullet, but it's defense in depth. I'm going to share here the open version of this so that everybody can kind of refer to it. But this is the way to protect yourself against this kind of compromise or packages. And as you can see, there are 600 on a weekly basis. So I hope this is useful. I'll put the links as well in below. But check it out. Let me know what you think. And stay safe out there. Use threat intelligence and agent firewall. And good luck to us all. Bye.